morning students, myself Muhammad Ashraf Khan, and today I am going to teach you chapter number 8, Oxidation and Reduction of class 11th. In our last lecture we have learned about what are the molecular and ionic equations. Here you can see the example of this reaction. It is written in molecular form because ions are not present here. If I convert it into ions, then we have to remember this: molecules, some molecules cannot be converted into ions or they never break down into ions. Okay, this one you will learn later, that which are the molecules which can be written in the form of ions and which are not. FeCl3, this can be written in the form of ions. Here 3 with Cl in the subscript, this will go to on the top of or in the superscript of Fe and it will become Fe3 plus. Okay, Fe has nothing, means Fe is 1. Okay, this 1 will go to on the superscript of Cl minus and it will become Cl minus 1. So you have learned this thing already in your 9th standard, that there is always cross. The charge, if you convert it into charge, there is a cross. The number which is here will go to on the top of the first one, and the first one subscript will go onto the superscript in the form of ion. The first ion is always positive and the second ion is always negative. Remember, for example, if you convert FeCl3 into ions, then what will happen? This 3 will go to on top of Fe ion, it will become Fe3 plus. Now how many Fe here? 2 Fe, so it will become 2 Fe plus 3. Now you see, Fe got only 1, there is only one atom of Fe here, okay, not here. You don't consider this one right now, okay, while converting into ion. So here Fe1 will go to on top of Cl, it will become Cl minus. So Cl minus, total how many Cl minus here? So Cl is 3 multiply 2, it will become 6. So here we write 6 Cl minus ion. Similarly SnCl2, this 2 will go to on top of Sn, it will become Sn plus 2 here. Okay, is it clear? And here Cl is always minus 1, so here 2 Cl minus ion, so we will get 2 Cl minus ion. Similarly here Fe will get plus 2 charge and Cl is always minus 1. So how many Fe? 2 Fe. So we write here 2 Fe plus 2. And how many Cl minus? Cl minus also 2. Oh sorry, 2 multiply 2, 2 2s are 4. So total 4 Cl minus. Here Sn how many? 1 Sn ion will get charge of plus 4. So we write 1 Sn plus 4. And how many Cl? 4 Cl here. And Cl is minus 1. So we write here 4 Cl minus ion. So in this manner we convert molecular reaction into ionic reaction. So students, in this chapter most of the time we use ionic reactions. Okay, we are not going to use molecular reaction in this chapter. So that's why I explain you before starting this chapter, because it is very important. Later you will not get trouble while understanding this type of reactions. So if remember student, if they on the both side of the reaction, this is the left hand side of the reaction and this is the right hand side of the reaction. If on left hand side and right hand side have similar ions, then we can cancel them. Here total Cl minus ion is 6 Cl minus and 2 Cl minus. So on left hand side total 8 Cl minus ion, and here also 4 Cl minus and 4 Cl minus. So we can cancel out both the ends. Assume if there is only 6 Cl minus on left hand side, but here 8 Cl minus. So we cancel 6 to 6 and the remaining ion we write here. Okay, then how many ions remain here? If there is 6 Cl minus, here 8 Cl minus, here we write only 2 Cl minus ion. Okay, but right now in this case 8 Cl minus on left hand side and 8 Cl minus is on right hand side, so both cancel each other. So we write only the rest of the ion. 2 Fe3 plus, okay, 1 Sn plus 2, okay, arrow, here arrow, 2 Fe plus 2, we write 2 Fe plus 2 and SH4 plus. So this is the way how we write a molecular equation into ionic equation. Okay students, there are some molecular forms which we never get converted into ions, like H2O. We have to write H2O in the equation as it is NH3, NO2, NO, SO2, CO and CO2. These are always expressed in molecular form. Please remember this thing, okay? And the ion, here Cl minus ion, here also Cl minus. On the left hand side, now on right hand side also Cl minus. So Cl minus on both sides means here is no change in the electronic configuration. Number of electron with Cl minus is same with the Cl minus of right hand side. So there is no change of electron. So we call such ions spectator ions. Okay. The ions which do not undergo any electronic change, because on left hand side and right hand side the charge is same. That's why we say that these ions do not undergo any electronic change during the chemical reaction. Hence they are termed as spectator ion. Please remember this one. Okay. The next topic we are going to start is oxidation reactions. There are a few examples. If you want, you can try by yourself. Write the following equation in ionic form. MnO2 is actually molecule. We cannot convert it into ion. 4HCl can be converted into ion. It is written, mentioned here. MnCl2 can be converted into ion. Water cannot, and Cl2 also cannot. Here we got 4Cl minus ion from HCl, 4HCl, and here got we Cl2. So Cl2 cannot be cancelled with Cl minus. Please remember. Okay, so in the ionic equation we have to write MnO2, 4H plus and 2Cl minus. From the right hand side cancel 2Cl minus ion, so remaining is only 2Cl minus ion on left hand side, and right hand side is Mn plus 2. Cl already get cancelled, we have to write 2H2O and Cl2. So this is the ionic form of this molecular equation. Our topic now start. I am going to start oxidation and reduction. The early ideas of oxidation reduction. The early ideas were based on oxygen and hydrogen. You have studied this definition already in class 10th. In the addition of oxygen is called oxidation as per the early concept. For example, magnesium, when treated with oxygen, it will give you magnesium oxide. So we call it, this is the oxidation of magnesium. Okay, this is the oxidation of magnesium because oxygen get attached with magnesium. Sulfur with oxygen gives SO2. So this is the oxidation of sulfur. CO, carbon monoxide, get react with oxygen, give you CO2. So here oxidation of carbon monoxide takes place. Now here you see sodium sulfide Na2SO4 get reacts with H2O2, which is called hydrogen peroxide. Now Na2SO3 get converted into Na2SO4, means sodium sulfide. Na2SO4, sodium sulfide get converted into sodium sulfate. Okay, so here you can see SO3 get converted into SO4. So here we say sodium sulfide, oxidation of sodium sulfide takes place in this reaction. So these are the few examples based on early ideas. Next is oxidation on the basis of removal of hydrogen. Addition of oxygen is called oxidation, or removal of hydrogen from any molecule is called oxidation. You can see student in this reaction H2S when reacts with Cl2, H2S get converted into 2HCl and sulfur is also formed. We can see here H2S get converted into S. So 2 hydrogen is removed from this molecule. Okay, so here we say oxidation of hydrogen sulfide. Hydrogen sulfide is this one. The oxidation of hydrogen sulfide takes place. Okay, but what happened with Cl2? Cl2 get converted into HCl, 2HCl. So we say reduction of Cl2 is taking place here. Reduction of Cl2 into HCl and oxidation of H2S into S taking place in this reaction. So this is how we read the reaction. There are two other examples. You try by your own. Next, this definition is also similar to the addition of oxygen. Students, remember, oxygen is electron negative. Please remember, oxygen is what? Electronegative. Electronegative means oxygen contains negative charge. Most of the time, oxygen is negative in charge. So that's why it is called electronegative. Hydrogen most of the time possesses positive charge. That's why hydrogen is known as electropositive. So the definition now based on addition of oxygen or addition of any electronegative element. Electronegative, oxygen is also electronegative because it contains negative charge. Or removal of hydrogen or removal of electropositive. Electropositive means which contain positive charge. Is it clear? So oxygen, we can give definition on the basis of oxygen, or we can say electronegative element, or we can give definition on the basis of removal of hydrogen, or we can say removal of any electropositive element. Addition of electronegative element, there is an equation Fe plus S means iron when get react with sulfur, it will give you iron sulfide. Here oxidation of iron taking place, oxidation of iron, because electronegative element sulfur get attached with iron, so this is called oxidation of iron. Here SnCl2, okay, gets react with Cl2 and converted into Cl4. So here Cl, we know already, Cl always contain negative charge. Okay, so it is a electronegative element. So electronegative element is added into Sn2 and get converted into SnCl4. So this is called oxidation of stannous chloride into stannic chloride. So this is stannic chloride. So stannous chloride get converted into stannic chloride. Similarly here also. Next, on the basis of removal of an electropositive element. Electropositive like hydrogen, okay, which contain positive charge. Here Ki, potassium iodide, when react with H2O2 means hydrogen peroxide, Ki get converted into KOH. Okay, Ki get converted into KOH. So here you can see I. Just now I told you already, the first like potassium, the first atom is always positive, atom or group of atom, they are always positive, and the next one is always negative. So here K plus, K is K plus and I is I minus. So here removal of electropositive element taking place in this reaction. Now we see Ki get converted into KOH and iodine is released. Here you observe oxidation of potassium iodide. This is potassium iodide. So potassium iodide get converted into which? KOH or I2 to get oxidized? Tell me a guess. So Ki when get converted into which one? I2. Who is removed? Electropositive element means K plus is removed. So here K plus is removed, after remaining is I. So Ki get converted into I2, it is getting oxidized. Okay, because K is removed, K is electropositive. Remember, so here oxidation of potassium iodide taking place into iodine. Similarly in the next reaction also, here also Ki react with Cl2, K react with Cl2 first and converted into KCl, and I get converted into I2. So here plus 1, K plus is removed, means electropositive element is removed. So here also oxidation of potassium iodide taking place into iodine. A substance, now it is very important definition student, please remember, a substance which brings oxidation is known as oxidizing agent. Okay, the substance marked with asterisk sign here, this one, this is oxidizing agent, because due to this oxidation of Ki is taking place. If you remove Cl2, the oxidation of Ki into iodine will not take place. So here Cl2 is called oxidizing agent, means the substance or the reactant which causes oxidation of another substance. Okay, so due to this chlorine, oxidation of Ki is taking place. Here in other examples also you can see, here sulfur is causing oxidation of iron. So sulfur here is oxidizing agent. Okay, see, oxidation of iron. So iron get oxidized by sulfur and converted into iron sulfide. So sulfur is oxidizing agent. Now we are going to discuss reduction. Reduction is just opposite of the oxidation. It is a reverse process. The definition, all the definition we will reverse. Reduction is a process which involve, according to previous concept, also we will study. Okay, and the latest concept we will study later. As you can see, CuO react with carbon. Okay, now carbon act here as a reducing agent. Okay, CuO, oxygen is removed from CuO. The CuO get converted into Cu. So we read it in this manner that cupric oxide get converted or get reduced in copper. Okay, but here carbon is getting oxidized. Carbon is oxidized into carbon monoxide. So here reduction of cupric oxide is taking place by this carbon. So we call this carbon as a reducing agent because it causes reduction of cupric oxide. So this carbon is called reducing agent. Reducing agent itself undergo oxidation. I repeat it again. Reducing agent itself undergo oxidation. You can see here this is reducing agent because it causes removal of oxygen. After removal of oxygen, carbon get attached with it and form carbon monoxide. So here, students, I hope you understood. Similarly, steam when react with coke, oxygen is taken by carbon. So here removal of oxygen taking place. So H2O get reduced into hydrogen. Okay, H2O get reduced into hydrogen and carbon is get converted into carbon monoxide. So here oxidation of carbon taking place and water get reduced from H2O to A2. Okay, this is steam. Okay, this is the reaction you are going to study in your hydrogen chapter, in the next chapter. I hope you understood. So here reduction of water is taking place. Water reduced into H2, and who is the responsible for this reduction? Carbon. So carbon is called an reducing agent. You can take other examples also. Addition of hydrogen. Now removal of oxygen, and next is addition of hydrogen. Students, see here Cl2 when react with H2, it gets addition reaction. This is the addition reaction example, get converted into 2HCl. So we say chlorine get converted into HCl. So here the reduction of chlorine takes place. Okay, it is written reduction of chlorine taking place in this reaction. But what about hydrogen? It is the reverse. Okay, if reduction of chlorine takes place, then here oxidation of hydrogen taking place. So hydrogen is taking place. So chlorine get reduced and hydrogen get oxidized. Okay, so here hydrogen is called reducing agent. Hydrogen is called reducing because it is undergoing oxidation. Sulfur plus hydrogen, you will get H2S when sulfur react with. So here you see that addition of hydrogen taking place with the sulfur. So hydrogen get added with sulfur forming H2S. So we read it in this manner: the sulfur is reduced. Sulfur is reduced into hydrogen sulfide H2S. Okay. So here hydrogen is causing reduction. So it is called reducing agent. Hydrogen is reducing agent here. Next, similarly, removal of oxygen or removal of electronegative element. If any electronegative element is removed, then it is also called oxidation reaction. HgCl2 mercury chloride reacts with SnCl2 stannous chloride and get converted into mercurous chloride. Here you see HgCl2, here HgCl2 and SnCl2 get converted into what? SnCl4. So here who gives chlorine? To SnCl2. SnCl2 converting into SnCl4. So who gives here 2 chlorine? So this 2 chlorine is given by this HgCl2 mercury chloride. So we say removal of electronegative element. You can see here Cl2 getting transferred to SnCl2. So here we call it reduction of mercury chloride is taking place into mercurous chloride. Mercury chloride into mercurous chloride. Okay, here 1 Hg have 2 chlorine. Okay, you can see 1 Hg have 2 chlorine, but here 2 Hg have 2 chlorines. Okay, the 1 Hg have 2, then 2 Hg should have how many? 4 chlorine. But here only 2 Hg have 2 chlorine. So where is the remaining 2 chlorine? The 2 chlorine get transferred from HgCl2 to SnCl4. Okay students, I hope this example is clear to you. I repeat again, here you can see 1 Hg with 2 chlorine. Okay, but here you see with 2 Hg there is only 2 chlorine. Here should be total 4. But in this reaction, the 2 chlorine atom get transferred from mercury chloride from this one to SnCl2. And SnCl2 get converted into SnCl4. Okay, stannous chloride get converted into stannic chloride. So students, I hope you understood very well. I am finishing my lecture here. In our next lecture, we will study from this topic addition of an electropositive element. Thank you very much. I hope you enjoyed. Bye bye.